How you doing? My name is Francis Umweke, and I'm here to present a project we'll be showcasing on CDay. And this project was executed for a class project. It's actually a class project, Advanced Machine Learning. And my team members are Long, Nathan, and Pablo. And instructor is Dr. Ramazan Aigun. For this project, we kind of utilized or leverage the robustness of large language models, LLMs. They are quite useful, and we already know what LLM entails in terms of like the power of GPT, ChatGPT, Claude, and the rest, and how useful they are. But as much as LLMs are very useful and very robust, they tend to also suffer from hallucination. That's sometimes when asked a specific question, uh, they tend to go off topic or generate answers that are not true, or also to sometimes they don't generate updated answer or out of scope. They don't really understand how to answer certain questions because they lack the domain knowledge. So one way usually to overcome that challenge is to fine tune an LLM. And when you fine tune an LLM, gives it that domain specific knowledge. So we take a generic LLM, GPT or Llama or Mistral or Pi or whatever LLM that is in question. We take that and we fine tune it on a domain specific data. So you take a generic LLM and you fine tune it on medical data, it becomes a medical expert and is able to answer questions related to medicine or questions that are very relevant to that particular field, in this case, medicine. So that's basically what we've done. We took a large language model, Llama, with about 8 billion parameters, and we used that to as our base LLM, our pre-trained LLM, and we scrapped data from the web. Like in this case, the domain knowledge for us here, or the domain specific knowledge for us is tech industry. So we wanted an LLM that is a tech industry guru, an expert in like answering tech industry questions and all that. So we scrapped data from online. We got the data, then we had to pre-process the data set in order to convert them to instruction set, because you have to fine-tune the LLM. So we took that and we did a little bit of data pre-processing to convert that data set uh, to be able to be in the format that it can be used to fine-tune an LLM. Then also in terms of fine-tuning, we use LoRa. LoRa is a technique for fine-tuning LLM efficiently. So rather than fine-tuning the whole LLM, the whole parameters, and updating the whole parameters, we fine-tune some certain parts of the LLM, which is much more efficient and much more cost effective in terms of like resources we have to use and all that. And it saves time too and gives you still like a robust, well enough to do model. So we did that. We used LoRa technique to fine tune the LLM after constructing the instruction set. And once we had our fine tuned LLM, then our fine tuned LLM was just more like then we could prompt it for um, domain specific questions. But in order to make that much more robust, as we already know, tech industry is a very evolving and very volatile industry. It changes quickly. So you can't really rely on data we got and we already scrapped and we already pre-processed and fed to the LLM, because as of the data we had yesterday could right now will probably be outdated in terms of tech. So to make our model more robust and more updated, we also included RAG, augmented retriever augmented uh, model. So we use that, we use RAG to improve the effectiveness of our model, so that our model is up to date, so you can get more information. RAG simply is more like just retrieving information from different sources. So it could go on the web and fetch data that is more updated. So if you ask it for questions that are pertaining to tech industries as of today, what's the stock of Google as of today? if you ask that to our LLM, probably can't answer that, or it's going to hallucinate because it doesn't have the information as of today. But when you include RAG gives you that more leverage and gives you that power to be able to go to the web and fetch more data, more up-to-date data. Then you're able to feed that to the user. So we have our interface. We also designed our interface where users can interact with our LLM and get feedback, ask questions, get feedback, be able to decide the maximum length of output they want and all that. So if you want shorter output, you could specify that. If you want a longer output, you could specify that. So basically done this for a class project, and we hope to see you on C Day, and have a good time. Thank you.